Okay, so good morning to all of you. This is the first day we have started. We are going to start the crash course on machine learning and artificial neural network. So what I have planned that we will first start the basic concept of machine learning, and then we will take a flavor on how neural network works and serves the purpose of machine learning. If you have any doubt or question regarding what we will discuss, you can ask me. Just I will after end of some slides or lectures, I will ask you. If you have any doubt, then you can raise your hand. Okay. So let's start the class for today. So start with we will start the machine learning class with, you see, in previous decade, even we didn't have any concept of machine learning. There was not some any system. We didn't thought that a robot can work everything. But in today's scenario, that scenario has been entirely changed. We can see that in every aspect we have a very important parameter present, that is machine, and machine can take decision by itself, and those decisions actually are helpful for most of the real life problems, so that we can solve the problems very easily and with much faster. And you see, you will find the application of machine learning actually everywhere. So the image is given just to show you that these are some very well known fields where machine learning is applied. But these are not only the fields. You cannot say that only these 9 fields are there. Actually, machine learning is applied any other fields in some way. So one by one we will see that. So first we will start the concept of machine learning with some formal definitions. You see, there are some expert comments from different perspective in previous years. Arthur Samuels in 1959 started the concept of machine learning. He said that machine learning is a field of study which gives the computers the ability to learn without being explicitly programmed. So here a very important point is given, that is given is ability to learn. How we can define this? For example, if I give you some book of some subject, and I told you that do one thing, you just read these first 2 chapters, then I will take an exam. After some couple of hours, you will say that yes, sir, I have already completed the first 2 chapters. So somehow we have learned something, but how we can express this? In real life, we cannot express by a definite function. So this learning concept is little bit, you know, it's fuzzy to define. So we will see with respect to a machine how we can define this learning. Moreover, a more important definition we have from Tom Mitchell in 1997 is given that a computer program is said to learn from experience E, and here we can find the definition of learn actually little bit more better definition of learning. is said to learn from experience E with respect to the some class of task T and performance measure P. If its performance at task T is measured by P, improve with experience C. So what is given, what he said? He said that if we have some experience E, now again another term is coming, that how you can define this experience, right? Just a minute. Okay, just a minute. Okay, so this is an important thing. Experience E. So how you can define this experience? Experience actually we gather from learning, right? So we read some book. Suppose the chapter that I told you to read, you will after reading the two chapters, you will have some experience on the basis of which you will basically uh, maybe you can give exam, right? Just a minute. Just a minute. Just a minute. Your friends has come. Anyway, so let's start again. A computer program is said to learn from experience E. Okay, so if we gather some experience with respect to some class of task T. Now, what is class of task? Class of task can be defined, can be considered as something like different type of different type of uh, cases. Different type of cases means when something is taught to you, we actually say various perspective. Now those various perspective are actually different type of class of task, and some performance measure P. This performance measure is the exam. So after reading the two chapters, I asked you to some questions which I have not taught you. Those are, and from from your answer actually I'm measuring how much you have learned. That is what we call performance measure. Now with all this measure, what we will do? It is said that if its performance at task T as measured by P improve with the experience, then I can say that you have learned something. I mean, you have, after reading the two chapters, when I asked you some question and you were not able to give any sufficient answer to me, so definitely I will say that from those two chapters you didn't have any learning. If you were really learned something, then obviously you were able to answer that some questions. So we expect that with the experience that we gather for the learning will basically increase the performance measure P, this one. So we can have some examples over here. For example, you see the class of task T is given as an example over here. For example, it's given as a traffic pattern. Traffic pattern as a busy interaction. So what we can do, we can run this through a machine learning algorithm with data about previous traffic patterns. Previous traffic patterns is what? Previous traffic patterns means in a consider a particular junction, and we have say various ways to go from the junction. Now throughout 2 3 junctions, what is the time when the uh, traffic pressure is very high, when the what is the time slot when the traffic pressure is very low, what is the time when the traffic pressure is medium. I mean, different type of scenario can be considered as a traffic pattern. Maybe that's an image, maybe something else, maybe something like a number of vehicles count, can be anything. So those forms an experience, and those experiences are actually learned by the machine learning algorithm. How it is learned? One by one will come. Now, one more thing, it's given that if it has successfully learned, it will then do at better predicting future traffic patterns. That is, we have considered as a performance measure P. So a very important thing present over here, that is future. That is future traffic pattern. Something like this one. So prediction is a very important task. Now see, it is not possible for us to visualize something after 2 years. What will happen? For example, we cannot say, we cannot basically say what will be the temperature at December month after 10 years. But somehow we can do it by statistically. So the previous, if we are able to keep some statistical uh, function that considers each and every, I mean, considers uh, the temperature at December month for a number of years, past years, those are actually the experience. In that case, maybe we can draw some conclusion on the statistical data, and that's actually done by the machine. So the machine learning that we are considering are sometimes also called statistical learning. So it actually learns the statistical behavior of the data. But better you can understand from the next slide. And suppose till now the traditional programming that we write looks something like this. That we have some computer, we write some program in some language, and then we give some input data, and obviously we get some output. For example, it's given a square root finder. So if the square root program is given somewhere and we put say 2, then we will get output 4. If we put 4, we will get output 16, something like this. Now question is that, suppose, assume a situation, I mean one thing is sure from here, that if this is x and if this is y, so this is nothing but a function f. So y equal to fx. And what this f is? F is actually expressed by this program. So program is actually representing some function that maps some input to output, right? Now assume a situation that you don't know the program. You don't know the program, but you have some data of x and data of y. Then can you build the program from there? The question is this. So if you exchange this one, that will come for a machine learning. What your machine learning is? Well, here the machine learning will work. The machine learning will try to understand the relation between the input data and the output, and somehow it will generate the program. So it will generate the program in the sense it will generate the function. Now understanding function exactly is not possible for us. So it will give you some form of parameters. The parameter values are somehow representing the program. So because program is not important. Important is that if we have some input data and some output data, then can I design the program? And if the program design is possible or the function realization is possible, then what we can do? We can use that program or function for some unknown input data to predict the unknown output, and that is important. So one thing is common till now, that is about prediction. This prediction is the highly important task where machine learning can be applied. For example, it's given in the example, it's given car fitting by linear regression. So what is linear regression? You don't know till now. We will discuss it very soon. Okay. So an example name is given just. So forget about right now about this one, this part. Now tell me, do you have any doubt over here, whatever we have discussed till now? If anybody has any doubt, please tell me, or unless I will proceed. Okay, so let's proceed. Now we will go for different types of machine learning problems. So we will see for the first one that we have is supervised learning. What is given? What is supervised learning? You see, we will try to understand this from real situation. So consider a situation. Consider a newborn baby who is just trying to interact in the world, and his or her parent and many other people are around him or her, and what they are doing actually, sometimes you will see that they show different objects to the baby and try to teach the baby that what is the name of the object. For example, consider a very a baby of say 5 years or 4 years or 3 years. So the parent sometimes take different fruits, may take, and show his children that this is apple, this is orange, this is banana, something like that, or maybe different type of objects, that is cat, that is dog. So now try to realize from the children point of view, the child is actually getting a child actually watching various types of object of various colors, and also the child is getting the name of the objects. So the different type of objects are actually those different type of, you can say, pattern, and the name of the objects that is given are actually what we call labeled. For example, if we consider only a data set of fruits, that some objects has labeled apple, some objects has label orange, some objects has label banana, and so on. So that next time, after some time, what happened? The parent doesn't need to show their child that what is the object name. The name of the object is already in his brain. He can identify. If someone asks you that give me an apple, the child will take an apple, not an orange, and give it. So somehow we can say that somehow the child has started learning about different type of fruits. And this is a very simple example with a fruit I have told you. But it can be for anything. It can be for different type of creature. Maybe he can see from image of a book. Even it has happened with us also. So I hope all of we can relate. And this is what a supervised learning is. So supervised learning means you will have some supervision of some person or someone else who will give you a data and will also say you that this is this type of data. With each and every data, what is the type of data is associated, and that is what we call, what is given over here is labeled. Now next come to the point unsupervised learning. You see, in case of unsupervised learning, if we continue with the same example, sometimes we find that we don't have any idea about, maybe when we were child, we didn't have any idea about the exact difference with respect to their name. But somehow we can say that if we have, say, 10 or 20 objects in front of me, we try to actually find a difference between various objects, and we find that maybe we will find that some objects looks like same and some objects looks like different. So we cannot say what is the type of the object, but one thing we can say surely, that this object and that object are not same with respect to some property. For example, when you are walking on a road and lot of people are coming in towards you, and among them some people are from American, some people are from maybe South Korea, some people are from Africa, and many other countries. Now if I ask you that tell me which one is from, this one is from, I just ask you that just tell me whether that person is from America or Africa or South Korea, something like that. Nobody has had tag that I'm from Africa and I'm from America. So the data that is given over there is not labeled. But with respect to their various properties, for example, the heights, for example, skin colors, for example, type of hair, you can say one thing at least, that I don't know whether that person is American or that person is African, but I can say that these two persons are from different region because they have different property visible in my eye. And this is what actually we call unsupervised learning. And that is why it is given that there is no teacher. I am not telling you that this type of persons are American and that type of persons are African. You are actually somehow by yourself realizing that these two persons are not from same region. Now how you are doing that? That is a part of learning. So one by one we will go through that. But this type of learning is called unsupervised learning. So that's why it is given there is no teacher. The data set is not labeled or classified. So it learns the insight of data without anyone's supervision. The next one we have is called reinforcement learning. It's a very well known and very important learning in our daily life. Each and everything that basically we learn is most of the time reinforcement learning. It is something like there is a teacher, but the teacher is not telling you what is the type of the data. Rather, teacher is criticizing you that you have done something wrong, you have done something right. For example, consider there is a baby, and after couple of, after some, in front of the baby, maybe after the distance of say 10 or 20 foot, there is something which a baby can eat. What the baby will do, baby will try to reach up to that point where the food is present and will take that. Now question is that which path the baby will follow. If we consider that the baby is present somewhere here and the food is present somewhere here, so baby can consider this path, baby can consider this type of path, the baby can consider this path, anything, anything, anything is possible, right? This path. So, but baby will consider this one. Why? Because it takes lesser amount of time. But how baby will understand? Baby doesn't have any idea. The child don't know what is the time taken to go in this direction. Actually, assume that if you take this path, maybe you will, the baby has tried with this path in previous cases, and he found that there are a lot of difficulties to reach over here with respect to time, maybe with respect to other parameters. That's why it is in his or her mind that this part doesn't go to result optimally. Now how he has got this? So that means there is two things over here. One is reward and one is punishment. If the baby reaches correctly to the point, it will get reward. If the child doesn't reach correctly to the point, the child will get punishment. So for different type of actions a child can do, for the different type of actions, either the child will be rewarded or will be punished. Now the point is that the child has to collect maximum reward to reach the point. Now how he will collect this maximum reward? This maximum reward, collecting the maximum reward in one chance is not possible almost. Actually, the child has to execute many try, and so that the finally with various points, child will ultimately find what is the best path to go from one point to another point that will lead to maximum reward. Take one more example, a very small example. Suppose we have a situation something like this. Okay. So suppose you are in this point, you are here, and your object is present somewhere here. This is the point that we have to reach from here to here. So question is that you can go any direction, either above or below or left or right, doesn't matter. The question is that which path you will follow. You see, if you follow in this direction, then also there is a possibility to reach. You follow in this direction, there is a possibility to reach. But if you go in this direction, we are actually, you are going more far from this object. So we can consider that we have a punishment getting -1 value, or in this side, or in this side, or in this side. If we go in this direction, I will get punished. That's why -1. If you go either of this direction on 3, then only you will get rewarded. So with all these different type of situation, ultimately you have to collect maximum reward from here to here. So that means when you are in some state, you can have different type of actions possible. Which action will lead you maximum reward? That's the reinforcement learning says. A very well-known example, practical example we never thought about, we never actually ignored that. For example, balancing. When we learn balancing, maybe for cycling or some two-wheelers, what is balancing? Can you define it? This balancing actually come from reinforcement learning, because we in our brain the idea come, then how I can share my weight, the weight of the cycle or scooter or whatever you can have, in some way, so that we can balance ourselves only in two wheels. And any other example would include, say, all the different type of intelligent games. For example, FIFA. So we have various agents over there. All the players are actually agents. The field is the environment, and on one player have, for example, one player that is controlled by you is only controlled by you, and if he has the ball with him, you will see that other players present in the field who are actually some robots is trying to take the ball from you in some way. Now, how he can do that? Not the all person will come. Some person will come, depends on some distance, and they will apply some technique to take the ball from you. That same applied for a normal situation. I mean, in a real life. So how those agents can try to understand where to jump and how to do this? Those all are actually a part of reinforcement learning. And a very well-known example is chess. When you give some move, in the other side, the robot gives another move against you. Now, how the robot decide that move will actually be the correct one? Because it's already learned that depends on some particular move to you, the robot can identify an action that will lead to some victory for the robot. Okay. So as a whole, we can find out that these are the, I mean, at least basic category of machine learning is, we have seen that supervised learning, unsupervised learning and reinforcement learning. Under this different type of learning, we have various type of problems. Under the supervised learning, you can see we have classification problem and regression problem, and unsupervised and under unsupervised learning we have clustering problem. And now naturally question will come, what is classification and what is regression? So we will go in detail for these two type of learning, but classification learning, one thing you can at least keep in mind that classification problem means we have some discrete label. The label that we consider over here can be either discrete or continuous. Okay. So if the label is discrete, then we consider it's a classification problem. If the label is continuous, then we can say it's a regression problem. So we will understand all these different problems with respect to various examples. I hope you can understand very easily. And under unsupervised learning, clustering problem is a totally different issue. So this clustering problem also we will see, I mean, some problems if possible, if time permits, and then if time permits we will go for reinforcement learning in latter. That's not our goal right now. So let's start from this point of supervised learning. What is given? That supervised learning is the machine learning task of learning a function that maps an input to an output based on example input output pairs. This is what we have seen in previous slide, where we had an example of square root problem. I told you that we have some input, I mean, if we have some program, the program gives some input and we get some output over here, and this is your program is, which is basically some function mathematically, which is mapping x to y. And here it is saying that the task of learning a function. So when we have x versus y, for example in a table form, in this way, some data is given, we don't have any idea about this mapping, and this is what the machine learning does for me, that the machine learning actually try to learn a function that can map this input to output, that is x to y, considering based on some examples of input output pairs. So this is the examples of input output pairs. Then it is saying that it infers a function from labeled training data consisting of a set of training examples. So a new word came for you, that is training data. So what is training data? All the data that is given, that is used to learn that function are called training data. For example, assume that you don't have any idea about data structure subject. What I have given you? I have given you a book of Shobhanan Chattopadhyay. And then I asked you that to read 5 chapters. So all the data that you will get are training data to learn data structure in the book. Now, obviously training data is not sufficient. Why? Because ultimately after that I have to take an exam. So naturally we have some more another type of data, that is what we call test data. So we will see that in future. Anyway, so for timing you just try to realize this one, that it infers a function from the labeled training data consisting of a set of training examples. So this can be considered as training data also. Okay, consisting of a set of training examples. So these are all examples, each and every example. So I have three examples over here. Example 1, example 2, example 3. In supervised learning, each example is a pair consisting of an input object, typically a vector. Now, what is this mean, that we will realize very soon. Okay, why it is I'm saying it is a vector, and a desired output value, also called the supervisory signal. So this is my output, desired output, and it is my input, showing that input vector. Now, what does it mean? Mean that x may be considered as a x1, x2, xn. So this is xi, suppose. Xi means the ith example consists of this one. What is this? So obviously xi is a vector, naturally. So xi is a input vector, and input vector contain x1 to xn. So what is x1 and what is x2 and what is xn? These are called features. What is feature? Let's see very soon. So an example application of supervised learning is given over here. An emergency room in a hospital, suppose, measures 17 variables. I mean blood sugar, age, of newly admitted patients. So consider a situation, a decision is needed. We have two things, suppose general bed and ICU. So a new patient arrived. Now depends on the condition of the patient, we have to decide whether the patient has to go for a general bed or some ICU. Now naturally ICU contain smaller number of beds and lot of costs are needed to, I mean, to go in that to go over ICU. So that is why very few patients can go. So naturally you have to consider which patients are in a high risk zone and which patients are don't have high risk. So how you can do that? You see, each and every patient contain those various measures. There will be some machine. So I'm expecting I will design a machine which will take those inputs. For example, gets given blood pressure, then age, maybe 17 or 15 other inputs, and will conclude either two things. One, it will be either high risk, and one will be low risk. So with considering these 15 various inputs, the machine can say this patient have a high risk, so he should be admitted to ICU, or the patient is in low risk, so he or she doesn't need any ICU. Consider another example, that a credited company receives thousands of applications for new credit cards. Now all the application contain all this information: age, material status, annual salary, outstanding debts, and many more. The problem is that I have to decide whether an application should be approved. I mean, whether the applicant should get a new credit card or not. because all the person are not obviously not capable to return the money that he or she will lend through the credit card. So when the credit card company gives you some card, that means he has taken all your informations, and somehow statistically the company has predicted that you have a capability to return whatever you will lend from the company. That's why your credit card is approved. So how it is doing this? So basically, from this various situation, one thing is sure, that we need some past experience so that we can teach to the machine. The machine can learn. For example, even human being also learn from past experiences. The problem is that computer don't have any experience. The question is that how we can create this experience for a computer, right? So naturally it's given that a computer system learns from data which represents some past experience of an application domain. What I mean is that we have some readily available, we must have some readily available set data that will contain those input and outputs, and that will basically represent the past experience and which will be useful for the machine learning task. So what is our focus? As we have seen that our focus is to learn a target function, the function that we are saying every time over here. For example, we must have some function over here. I don't know what the function is, that we have to learn this. We have to learn this function, and this is also called target function. That can be used to predict the values of, as I have showed you, discrete class attribute, consider as a classification, or for example approved or not approved, maybe high risk or low risk. These are all discrete or continuous values, what we call regression. Okay. So this task commonly called either supervised learning or classification or inductive learning. So one by one we will see that. Okay. So now let's come to the point that the data that we are discussing about every time. What is this data? You see, data is a set of records, a set of records, or also called examples, and described by this way: k attributes and a target feature. What is this target feature? What is this k attributes? I have written in this way, and target feature means those label, or you can say the desired output. Now, as we have seen that our goal is to learn the model for the target so that it can predict the target feature for some new cases, and new cases are called the test data. This is important. So our data set looks something like this. You see, it is a table where our input consists of these three things, you see, and this is the only output. So in previous case, as we told you that we have feature vector. What I mean that this pattern 1 is not a single value. It is a combination of x1, y1 and z1, which can form a vector. You can consider in this way also, you can consider in this way also. It is row vector, it is column vector. That is the only difference. So you can express in either form. Now you see this word you have came again, feature. I was telling in my previous slides that each and every x1, y1, z1 are features. What is feature? Feature is defined as the property that describe each pattern or instance. What I mean? Take an example. Think about feature of, say, consider a human being. The feature can be you consider as a skin color, can be the uh, uh, can be hair color, can be height. So with respect to these 3 or 4 properties, you can easily identify a people from America and a people from Africa. But those cases, those property, are these only property of a human being? No. You can also consider a property as a number of eye, or number of leg, or number of hand. But it doesn't have any any new information that can identify two different, people from two different region. Because number of eye is always same. So we will not consider the properties which are common for all different patterns. These patterns are actually the objects. Okay. So we will consider only those properties, those which are common for some particular type of pattern and are not common with some another type of pattern. And only those properties we call as a feature. For example, if you consider that we have some data set of various creatures, various animals, for example dog, cat, lions, or maybe elephant. Now suppose that in the data set we have pattern of 3 dogs, 4 cats, 2 elephants and 7 tigers. What will be the features for the patterns we can consider? We can consider feature as the skin color. We can consider the feature as a, say, length of the animal. But you cannot say feature as number of legs, because number of legs are 4 for all the animals. There is no difference. But if you consider skin color, or maybe the color of their hair, then you can say that 2 elephant will have some similar type of color, 3 cats will have some similar type of color, 4 dogs will have some another similar type of color, but they are dissimilar with respect to each other, and those only we consider as a feature. So if you go for visualization of this feature space, you see that we have our data something like this, right? X and y, and what we have seen? We have seen that we have some function. One thing we have seen surely, that we have a black box over here. What we don't know, we have some input and we will get some output. It depends on this input output mapping. The machine learning will basically represent this function. So the data set xy that we have is y is what? Some output from this function due to the input x. That is why it is given fx. So f is the given as the target function. F is the target function. If we assume that we have idea about the target function, then I can easily write xy means x of x and fx. Now, obviously these 2 points also we know that if this fx is discrete, then it is a classification problem. If this fx is continuous, then it is a regression problem. That's all. So suppose that we have this n number of features that can form a feature vector. For example, what I mean? It means that this x is made up of x1, x2, x3, xn. 1x. In this way, I have multiple x's, multiple x for multiple examples in the data. So, you see, if I consider this as a vector, what I mean that if I have in number of features, we can just consider a situation we have 3 features. Forget about n number of features. We have considered 3 features, x1, x2 and x3. These 3 features we can consider as a 3 dimension in a space. Each and every dimension assuming a features. For example, given over here, that suppose according to the previous example, over here we had x1, y1 and z1. So you see that we have a dimension for x, a dimension for y and a dimension for z. Anybody has any doubt? Anything want to say? কেউ কি কিছু বলতে চাইছে? So this x, y, z considering some dimension in a space. So if you consider the first pattern, just try to imagine this one, that you have some 3-dimensional space of features, and in the space the pattern 1 that's representing x1, y1, z1 is a point in that space, and that point can be represented as a vector x1, y1, z1 that I have written over here, drawn over here in this way. We all know that vector is drawn from the origin 0, 0, 0. In this way, we have many patterns. We have many patterns in the space, and each and every pattern has some point on the space. So basically, how you can visualize a data set in a space, you can visualize as some number of points in a space which can form a cluster. Cluster means which are very close together if the points are similar type of class. Now, naturally, with respect to 3-dimension, it is easier to understand. But sometimes if we consider the real situation, you don't know this value of n. Suppose you don't know this value of n. Maybe it can 10. So that means each and every feature, if we consider as a dimension in the space, then for 10 features we have 10 different dimensions. Now after 3, in real world dimension is not possible. because 3 into 120 equals to 360 degree. So after 3 what we have, all are considered as a hyperspace. Maybe if we consider a 10-dimensional space, that is become a hyperspace. That is beyond our imagination. But still, if you try to relate the same thing with respect to 3 dimension, then also one thing is sure, that each and every pattern is nothing but a point in the space of the features. So assume that we have this is the uh, just a minute, this is the whole feature space where one point I have only drawn. Now if we try to realize this one from a 2-dimensional point of view, it will become something like this, that we have 2-dimension x and y where we have some points clustered together. Okay, so these are the actually depends on the different values of x and different values of y, I can easily get the point. So I can say, since I have 2 dimension, that means each and every instance or the pattern have the input contain 2-dimensional input. That means input is a vector of 2 components, x and y. That's all. So from different values of x and y, I can easily get these points. So this is one set of data in the data set, but only this is not there. At least one more different type of data will be also there. I mean, what I mean say that if some people come in front, if the people that you can see in front of you all are from American, then there is no way to segregate with each other. So there must be some person from different regions. So that means other than these points, there must have some other points also. For example, consider this one. These are some other points which are representing for different value for x and y. These are the other points, but they have the different characteristic. Maybe the yellow points representing some characteristics of American, and the green points are representing some characteristics of some African. Depends on some x and y. Now what is the task? Task is that if a point is given to you, given in red, and we'll ask you that this unknown person is from which side. So what you have to do? You have to put some classification boundary in between this yellow and blue point, yellow and green points, and then only you can take the decision. Until we have this boundary, we cannot make any decision. So we need some boundary, something like this. This boundary will tell you that definitely this red unknown was maybe from Africa, because this red point is outside the boundary of the Americans. And what is this? This is the target function we have learned. Actually, the machine has learned somehow by different machine learning techniques. That may be supervised learning, they may be not unsupervised learning. I'm not going in the specific supervised or unsupervised learning. I'm trying to say that this is the way of doing a job. So the machine learning in task, I mean the the black box which is basically learning is actually drawing this function, and that function is actually making a boundary which is the, you can say, uh, which is basically discriminating between two or more different type of points, and then only we can take a decision with respect to unknown value. So this is our unknown point. Obviously this is my unknown point, and this is what actually part of testing. So at the time of training means that when I, obviously before we find this classification boundary, we have to train the machine. For example, something like before we give exam, we read books, we understand the subjects. That's a part of training for us. So when we get training, then only we actually uh, this, I mean, with respect to machine, if you consider, we can draw this boundary and then we can complete our job. An example of this is something like this. You see, the loan application example that we have just seen in 2-3 slides ago is something like this. The data set looks something like this. That some specific type of different type of age, different type of job, with respect to all these are features. This is a feature, this is a feature, this is another feature. So one thing I can say, that each and every pattern contains 4 features. That means we can assume that we have a 4-dimensional space or a hyperspace where each and every person is defined as a point having 4 vector components, 4 components vector. And one more thing is there, that is class. So class is also a, you can say, I mean, also a dimension. Class is also a dimension, but this is output dimension. So depends on various inputs, this will be the output. Now this data set actually learned by the machine. So this is our examples, or also you can say the experiences that a computer use to learn by itself, so that if a new application come, something like this, so it's given that young, false, false, good, this different criteria, age is young, as job false, own house is also false, credit card rating is good. Maybe this type of combination is not present when we had a learning we had only with these objects. So if you check this type of combination is present or not, young, false, false, good. Okay, we had young, false, false, good, fine. But one thing is sure, that every time the attribute values or the feature values given over here will not be same, may not be present in the training data, but still the machine can understand, can predict what should be the class, and that is the usefulness of machine learning is. So we can stop our class over here for today. From the next day, we will start this supervised learning in more detail. Thank you. So any doubt you have? Any question regarding what we have discussed or anything? Any? Hello? Yes. I'm sorry, I'm sorry. I'll just ask you again. Ask me again. Hmm. Hmm. Do you know what is overfitting? Overfitting is different issue actually. Overfitting is different issue. Whatever you are saying is not overfitting. It's actually you will not. For example, 100% accuracy এলেই overfitting হয় না। এটা ভুল ধারণা। Lot of misconceptions are there. I can see. Who has told you that if there is 100% accuracy, then there is overfitting? Tell me one thing that when the curiosity, you all know the name, right? That's a robot sent to the Mars, right? The curiosity is actually not only a simple robot, it's actually a human being, right? So when this type of devices is uh, designed, what do you think? Are scientists consider any sort of precision in their error? Everything is designed with zero errors, right? All this device has to design with zero errors. No, that means it can work 100% with 100% accuracy. It has to work. There is no way that you will have a mistake of 0.0001%. Then the machine will simply will washed out over there in that temperature, in that space. So 100% accuracy actually is very good, but it does not mean that we have overfitting. Overfitting is totally different issue. I will discuss this overfitting over here. Before we go, we will see various. I will show you even with an example that how actually learning is happening. But that's a later stage. Before that, we have to go through all the theoretical part. That theoretical part in the sense that how everything is doing on, and then we will go for mathematical portion. But there also I will show you what is overfitting and what does it mean. But you don't we take with this type of concept that 100% accuracy mean overfitting. Okay. Any other question? Okay, so then we can stop over here. So maybe if I cannot see within this week once again, we will sit in next week on Monday again. Okay. 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 I will share the video to you, and maybe if possible, even if you need, then you can visit that again. It's I will send you one by one. Okay. 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 Bye. So I'm just stopping my presentation and leaving. Okay. You can leave the classroom also. By the way, one thing, all of you please join the WhatsApp group so that if any anything to say from my side, I can tell you. And if you have any query, you can post the query over there also, so that everybody can um, so that everybody can uh, you know get your view also. Okay, so that's the WhatsApp group is given just for a very clear discussion. So please join over there. That is my suggestion.